Alright, so what are discontinuities? They are pretty much anywhere where the graph is not continuous, obviously, by the name of it. So what does that mean? Any point where you have to pick up the pen to graph it again would be a discontinuity. So for rational functions, that's going to be our vertical asymptotes and our holes. Pretty much any domain restrictions is going to be a discontinuity. So if I was graphing number 13, all right, I would find my vertical and horizontal asymptotes, plot them, plot my x and y intercepts, and then connect the dots. So I would graph this part of the graph, and then notice I have to pick up the pen to jump over this point right here because there's a hole. All right, so I have a discontinuity at -2, which is because there's a hole. And then as I keep graphing it down this vertical asymptote, I eventually have to pick up my pen and then keep graphing it up here. So that would be another place where I had to pick up my pen and skip an x value, and that would be at -1 because there's a vertical asymptote. So this graph has two discontinuities at -1 and -2, and one happens to be a vertical asymptote and one happens to be a hole. And those are the only two places where you're going to get discontinuities in a rational function. All right, so pretty much any zero of the denominator is going to be a discontinuity.